on the structure of the atom, we're talking about the plum pudding model. Was the old model. A scientist called Thomson was sort of behind this model. Now, we see from the picture here, there are these negative particles that they knew were in there somewhere, and they kind of assumed the rest was this kind of mush, this mixture of other parts, which they didn't know what it was like. So they knew that the atom, parts of it had negatively charged particles in there. They also knew that the atom had no overall charge. So what does that tell them about the other bit, not the particles, the other bit? Well, if the atom is neutral and bits of it are negative, then the other bits must be positive. Okay, so our next bit, we've got these two scientists, Rutherford and Marsden, and they did an experiment, and this is the classic, oh, the model is wrong, we need to change the model experiment for the atom. They were firing these alpha particles, okay, these little particles made up of 2 protons and 2 neutrons, into a very thin sheet of gold. Okay, from the old model, the old prediction, they only expected about 4% to, they only expected a very few of these particles to be scattered by more than 4%. So what does that mean? It means it's got the gold leaf there, and the vast majority of these particles are going to go straight through. And every now and again, they thought there might be a tiny little deflection, but not many and not much. But they did over 100,000 experiments or measurements, and the results of this caused them to change the model. They needed a new model. Why? Okay, so what they found was there were lots more deflections than expected. And those deflections were also larger than expected. So in simple terms, what we could also add in there is, so the evidence from the experiments did not match the old model. So they needed to introduce or think up a new model. Okay, this last one's a little sneaky. So we've got to describe the new model for the structure of the atom, and key points. It actually tells you what you've include. You've got to include the individual particles, and you've got to mention their relative masses and their relative charges. But this is the nasty bit. This bit I don't like, actually. It says do not include a diagram, because it would be easier to do this with a diagram. Okay, so we need to say then, and we're not even going to doodle on the side here. Shouldn't do that. If it says don't draw a diagram, follow the instructions. So we say there's a nucleus. We need to include the fact that there are protons and there are neutrons. Obviously, I'm not doing the bit that says we need to use good English and organization. Okay, you really should write this out as full sentences. But so we've got protons and neutrons there in the nucleus. Okay, they both have a mass of 1. The proton has a charge of +1, and the neutron has no charge. And then we can also say in shells around the outside, there are electrons, and they have a charge of -1, and the mass is about 1/1800th or you can also put negligible, or you can also put much, much smaller than the protons and the neutrons. Okay, so have we given everything? Have we explained everything? We've described the model. We've given the names of individual particles. We've said where they are. And we've also given their masses and their charges. So yes, we've covered everything that they've asked for.